So, hi everyone. Thanks a lot for joining our meetup, and also, of course, happy upcoming International Women's Day. Sorry. The fear of public speaking. This will be a part of my talk later on, and it's here right now with us. Anyway. Before we start, I'd like to share a little bit about organizers and, well, what's going on. The Tech Internals community and Tech Internals Conf are the guys who create this amazing conference for developers of highly loaded and complex systems. And, well, they're hosting this meetup and lots of other meetups, but our main event is the Tech Internals Conf. Surprise, surprise, this QR code is working. That will take place on 26th of May here in Berlin. And, well, I'll share something about it with you. And our partners today is Women in Agile in Berlin and Zalando. You will hear a lot about them today also. Thanks for the partnership and your participation. It's always great to have some partner in crime, right? Tech Internals are not some new guys when it comes to organizing events for developers. They've already hosted like more than 100 events in 4 countries. So now it's just time, I guess, to take their expertise and all the best practices here to Berlin, the biggest IT hub in Europe. And here you can see key topics for the conference in May, and this QR code leads to the full lineup where you can check it all. What to mention here? Well, Tech Internals is a conference from developers and for developers, so it will be like strictly technical without any soft skills talks and really practical oriented. These are the top speakers from the previous conference, as you can see, really practical. And also these guys represent the most interesting international companies such as Netflix, Amazon, Red Hat, Airbnb, and others. And speaking of community, usually this conference is attended by mostly middle-class developers, so it's a nice crowd to connect with and like exchange some ideas. So why do people attend Tech Internals conference? Of course, the main value is top speakers and cutting-edge topics, but it's also important to have this opportunity to connect with a community of like-minded professionals, not just in strictly professional way, but also on a fun after party. And, well, this is it from me for now. Mariia, the stage is yours. Please come join me, and we need some help, I guess, with the microphone here.
All right. Thank you very much, everybody, for coming and for finding time in this fine, warm spring evening. So I'm Mariia, a senior applied scientist from Zalando. At Zalando, I work in recommender systems. So basically, if you're familiar with our platform, whenever you open the app or the homepage, the content that you see is highly personalized for you. And behind this is me and my team. And today, I'm going to talk about transformers and how they power the current landscape of AI. So the agenda for my talk is the following. First of all, I'm going to give you a brief intro, how like transformers are actually taking over the AI, where they're staying behind, where probably you don't even suspect that these are transformers. I will briefly go through the history and how they evolved, where they actually appeared, in which domain, and how they expanded beyond this domain where they first appeared. I will deep dive into the core mechanism of a transformer, which is called a self-attention, a very important thing. I will describe two real-world applications of a transformer that I was actually implementing at Zalando, because I worked at two different teams, and in both of them we applied transformer architectures very successfully. And then I will finish briefly talking about the next wave of AI architectures. I will focus on the ones that I find the most exciting. And we will finish by the Q&A session. In case you feel that your question requires an instant answer, please feel free to ask. If you're feeling that lacking understanding to follow my talk, please feel free. But apart from those questions, I would advise to keep them till the end. So, transformers. I'm not sure how many of you are actually familiar with transformers beyond the context of popular movies, but I'm sure that all of you are familiar with ChatGPT or Gemini or TikTok or YouTube. Maybe less of you are familiar with models like AlphaFold, which predicts molecular structures, but if there are any biologists here, I'm sure they do know this. Or, for instance, the SAM model from Facebook that does segmentation for VR. So behind all these applications, we have a deep neural network structure, which is called a transformer, that is actually doing the work of reading, for instance, the prompt that you feed to, say, ChatGPT or Midjourney, and then outputting the video or the image or the answer to a question. All of this is done by a transformer. So, evolution of transformers. Let's go through the brief history. First of all, they appeared in natural language processing. So people have tried to solve tasks like machine translation. So basically, when we have one sentence in English, we want to translate it to German, and we want the machine to do this. Or another task, answer the question. Or given a document, give me a brief summary of what's contains in the document. The models that could perform this sort of analysis existed for quite some time. The first era of these models was called recurrent neural networks. So basically, it's a sequence-to-sequence type of model which takes in one sequence of words and outputs another sequence of words. And all of these models processed sentences word by word in a sequential manner. So basically, to get the final output, you need to process one word after another. You cannot process, for instance, like on this graph on the bottom, you cannot process x3 before you have outputs first from x1 and then from x2. So basically, you have to wait all the time to proceed with your operations, which of course limited their capacity in terms of computational power and speed. There were several different variations of recurrent neural networks. They were upgraded in 1997. You can see that this was done quite a while ago, when the hardware computational power was not even there to actually perform this in real life. So this was still at the stage of computer science development. So it was not implemented even. So these LSTMs developed by Schmidt-Huber, a very also prominent computer scientist in natural language processing domain. He invented them in end of 90s. They called long short-term memory units. They tried to solve the problem of the RNN, the problem of forgetting the information. So basically, the problem when you process information sequentially is not just the time that it takes to process it, but basically that by the time you reach the final word, you forget what was at the beginning. Or basically, you lose this information. So LSTMs were intended to solve this problem, but still it was there because it was still the sequential type of processing information. So fast forward 20 years from 1997 to 2017, we have a paper from Google which absolutely changed the landscape of natural language processing. The paper that was called "Attention is All You Need." Maybe some of you heard this title because it's super popular, especially now. If you check Google Scholar, it has over 160,000 citations, and I think it's one of the top 5 or top 10 most cited computer science papers. I think it really increased in the past 2 years because of the explosion of LLMs, large language models, which power stuff like Gemini and ChatGPT, because all of these papers use transformer, and then of course they like refer to this paper. So what was different? We don't need to process one word after another anymore. We can basically feed the full sentence in one go, or even the full abstract or the full document. This approach completely changed the way how we process text. So as you can see on this, I tried to plot this below the text. So you can see that this x1, x2, etc. Would be the words of the sentence. And here you do not need to wait for the output of x1, and you do not need the output of x1 to compute the output for x2. So all these things can be computed in parallel, and that's the beauty of the transformer. So I'll just continue going through the history of the revolution, and then we'll do a deep dive into the architecture itself. After the paper was published, transformer architecture started being adopted by real-world applications. I think the first one was Google Translate that was powered by transformer. Basically, Google had Google Translate before, of course, but it used this neural machine translation model, which was based on RNNs and was quite slow. But after this, they implemented this hybrid model. So part of it was still running on this neural machine translation model, but the other part was running on the transformer. And it allowed to roll out the model on the mobile devices because it became much faster. After that, we have BERT, which is bidirectional transformer, meaning that it processed words not just left to right, like we are used to in maybe not all the languages, but majority of the languages. It also processes the words right to left. And it powered Google search. So it really made it much more efficient and fast. Transformers keep evolving. In 2019, we have GPT-2, which is perceived to be the first AI model to generate human-like text. So basically, this was the first, not the first generative AI model because there were GANs before that, but it was generating really human-like text, very cohesive, and it could create stories and even write code. But transformers go beyond that. They go into vision. So here we have Google researchers again, who claim that you can actually apply transformer not only for natural language processing, but for image processing. How do we do that? You can think of an image as a sequence of very small images. So you break it down into this small, they call them patches. You put them in a sequence left up to bottom right. And you feed them to the transformer. Basically, like image can be encoded in this RGB channels numbers, and then you feed this the sequence of these patches to the transformer. So Google rolled out this paper vision transformer, which solved the task of image classification, object detection, and segmentation. And next comes the video transformer. So if we treat an image as a sequence of patches, we can treat a video as a sequence of video frames. So basically now we have two dimensions, space and time. But again, we end up with a sequence which we can feed to transformer, and then transformer can analyze the video. And it continues. So 2022 and going forward, transformers power most of the generative AI. So models like Flamingo from Google, which was, I think, first to merge text, vision, and audio modalities. Then there was this model from Google DeepMind, a robot transformer, which actually learned the real-world reasoning. So it was trained on, I think, text and image data just available on the internet. But it allowed the robot to train to learn motions, to basically decide in which direction to move. And there's also just this amazing AlphaFold model, which I really like, which is applied in biology to predict protein and more molecular structures. It's less famous, but I think it's also like very amazing. So why are transformers so powerful? And what is actually a transformer? As I said before, the main breakthrough was a completely different approach to data processing. So on the left, you see the pre-transformer era, which is processing words one by one. They call them tokens. So a token can be not necessarily a word. It can be a part of the word, like a root of the word or a suffix or a prefix. In case of images, it can be these patches. So basically, that's a token. Transformer processes them all at once. And these operations are parallelizable, which makes them fast to train. You also have the possibility to learn connections between distant words, which for recurrent neural networks was a struggle. And here I put an example in German. I'm not sure how many German speakers we have in the audience, but I think German language is actually a very good example overall, because when I started learning German, I was amazed that sometimes you have the verb, like the stem would be at the beginning, but then the prefix, which actually defines the meaning of this word, would be at the end. This was mind-blowing for me. And RNN struggles in this case, but transformer doesn't, because it can definitely say that stehe needs auf, and auf defines the actual meaning of the word stand. So it's not just standing, it's actually waking up in the morning. Yeah, this sentence means I get up every day at 7 a.m. Yes, so as I said, simultaneous processing, which allows the speed up, which allows to relate distant words. And another thing, it turned out that transformers are capable to learn general knowledge. So this is basically what ChatGPT is doing. It is being fed a lot of very different data, very different texts, and it learns the general knowledge basically about our world. And the cool thing about this is that you can train this general knowledge model on a large amount of data, which is like not really related and is not united by some one domain. But then you can fine-tune it for a specific task. Like for instance, GitHub Copilot, which is this wonderful coding assistant. The basis of this is GPT-4, but then it's fine-tuned on a specific data set, on a corpus of like coding snippets. And so in this way, it becomes a coding assistant. Let's take a deep dive into the transformer architecture, because I keep repeating this word, transformer, but what it actually is. So on the left, you have the architecture of a transformer as it was initially presented in Attention is All You Need paper. There are two main building blocks. There is encoder on the left and decoder on the right. So basically, if we take an example of machine translation, we have one sentence, say in German, which is fed to the encoder. It encodes it to some numerical representation, and then decoder must decode this representation into a sentence in English. So on a high level, this is what's happening in a transformer. So there's an encoder, there's a decoder. If we're talking about like a multimodal model which generates an image by the language prompt, then of course, like as an input, you would have the sequence of words. As an output, you would have an image. But like, what's the beauty of it, right? I mean, if you look at it, it's again like some layers stacked. There's add, batch, norm, feed forward, very generic stuff that like all neural networks use. But the key thing here is this orange box called multi-head attention, which in the classic paper, we have once in the encoder, and then it's applied twice in the decoder. And this is the core thing of a transformer, basically where the understanding of the input is learned. So what's happening there is basically just matrix multiplication. So we input the sequence, We can look at it as follows. So there are 3 matrices that learn the information about this sequence. They're called query, key, and value. And you can think of it as you have a question, which is your query, and you go to a library, which has a bunch of books, which is defined as key here. And then value is actually the information in these books that is relevant to your question. And the idea is you match your query against all the books, so Q multiplied by K, which is this formula on the top, which says attention equal. You do the scaling, which is for like gradient stability, and then you multiply it by this representation of all the words that you have, and it helps you find the most important words or like the most relevant books. Because what is output from this purple box are what is called attention scores, which is actually the importance of every word to another word. So this purple stuff outputs this matrix, which is called attention scores, which is exactly sequence length by sequence length. So it's a square matrix. Sort of like an adjacency matrix for a graph, but not really, because like it's dynamic. So then, like if we take the sentence, the train left the station on time, you can see how every word relates to another one. So like the word to itself has a 1 because it's like maybe most important for itself. And then you can see, for instance, in this example, there are 2 particles they, and the one that is next to the station has a higher correlation or like higher attention score than the at the beginning, which refers to train. So you would have like 0.3, which is higher than 0.2 because this word is more relevant for station. So this is briefly what's happening inside the transformer. So the idea is very simple. As I said, it's just matrix multiplications. There are no any complicated formulas there, but it's really beautiful because through this like backpropagation mechanism of a neural network, it actually learns these weights and it understands which words are the key in this sentence, which words produce the meaning. Going back to the slide, you can see that there are actually several of these attention blocks. So like scales, dot product attention, or self-attention, these are all the same things. They also call it attention head, and as I said, there are multiple of them. So why do we have multiple attention heads? This is also a very important point, because when you have a sentence, the words can be connected via different relations. So for instance, they can be different parts of speech, like verbs, nouns. Then every word can contain some meaning, so you would talk about semantics. And there's also the general context of the sentence. For instance, take the word bank. In certain contexts, we would talk about a financial institution. In another context, we would talk about a riverbank. And so these multiple heads, this picture, by the way, is also AI generated. And I try to use AI tools as much as possible. I think it's really cool. So these multiple heads are intended to learn these different kinds of relations. Another good example is images, because you can think of it as like each head is sort of like zooming out in an image. So first head looks very closely and you learn textures. Next head zooms out a bit and you learn edges of the objects. The final head zooms out completely and it learns like the objects themselves. Yes, so I also put some examples to illustrate what's happening. Let's take the text. The sentence, these are 2 different examples. The sentence is almost the same except for the last word. So on the left, we have the animal didn't cross the street because it was too tired. On the right, the animal didn't cross the street because it was too wide. So apparently, in these 2 sentences, the word it refers to 2 different nouns in the sentence. And the beauty of transformer is that it will actually learn higher weights to the proper noun So in the first case, you can see like the brighter color indicates the higher weight. So it understands that in this case, it refers to an animal because it was an animal who was tired. And then in the second case, it understands that it refers to a street because it was the street which was an obstacle for the animal to cross it. I think it's just amazing. This is another illustration of attention scores for images. I apologize for bad quality, but it's actually trained on this like small pictures, so it's not possible to make them bigger. It's a heat map. So basically, the warmer the color, it means the higher the score is. And for instance, in the like you can see that it actually detects the edges of the object. I'm not sure if you can see it from like the further rows, but like in the bottom row, second from the left, there's a horse on the picture, and it actually like the heat map almost precisely like shows the shape of the horse. So it actually learns. And this is inference. So after the transformer is trained, we run inference on the images. So basically like the prediction. All right, so beyond NLP, as I already mentioned, I talked a bit about images and videos, how we can think of an image as a sequence, and basically we can apply a transformer anywhere, almost anywhere, where we can represent our data as a sequence. So apart from videos and images, you can think of time series. There are other challenges for a transformer in time series, but basically it's also possible to apply them for time series, and I think Zalando did this very successfully. When I worked in my previous team, we actually implemented a transformer to forecast the articles that we sell online. I'll talk about it in a bit. And another very interesting application is recommender systems, which we also do at Zalando. So I will focus on these two use cases because they're like I worked on them in real life. Time series forecasting. Zalando faces the following challenge. We have around 1 million articles that we sell online, like different positions. And we need to produce a forecast for them every week for different time horizons, for different purposes. For instance, like short-term horizons for setting optimal discounts, long-term horizons to replenish stock, and this all needs to be done fast, regularly, and accurate. So, as Zalando was scaling up, we started selling more and more different articles. We expanded in different countries. So apart from like multiple weeks and multiple positions, we need to produce forecasts for 25 countries. So models like old-fashioned time series forecasting, Rima, or even XGBoost started to struggle. And they came this idea, like, why not try out transformers? And actually, transformers helped to solve the problems with which the previous models were struggling. Because basically, in our case, we process all the items in one go. So we produce forecasts for all items simultaneously. And the benefit of a transformer is that we have basically, like the distribution looks like this. So we have very few high performers and high sellers, and then a very long tail of items that sell rarely, but still we need to forecast for them. And the benefit of a transformer is that this low performance can actually learn from high performance if they're similar, because the transformer architecture would allow for that, would allow to see basically how much they're correlated and how similar they are, and propagate information from dense articles to like sparser time series. Yes, as I said, it also captures complex relationships between covariates like seasonality or price elasticity, because it's very important for us to understand the dependency of sales on discounts. And for instance, we implemented this enhancement. We forced the transformer to be monotonic on discount, which is like, logically you would think it works like this. You set a higher discount, a lower price, people buy more. And we would want actually the model to reflect that. But if you don't like specifically implement this, transformer will not do that. but the flexibility of the architecture allows to do that and like to make the model output like closer to real life. Yeah, so basically now our forecast runs on a transformer, but it's not the end. We also use transformer for recommender systems because how could you think of a recommender system to embed it into like the sequence representations? So every digital platform keeps track of your actions, which also form a sequence. So you come to a platform at a certain time and you perform a certain action, and this is logged. So basically at Zalando, you would have a sequence of items that you viewed, then probably at some point you did add to cart or add to wishlet, at some point there was a purchase, and so on. So in this way, user history can be represented as a sequence, fed to a transformer, and for instance, we can predict the next most probable item to be clicked. This was actually done by computer scientists from University of California, San Diego, back in 2018. They implemented this self-attentive sequential recommendation, which I think is really cool. Yeah, because basically they did what I was just describing, predicting the next item that you're most likely to view or purchase based on your previous history. It can actually go beyond that and be used in multiple downstream tasks because you can not just predict the next probable item, but you can actually, using a transformer, create this numerical representation of the customer, which can then be used in multiple different downstream tasks. So the transformer would output this sequence of output tokens, which then, for instance, you can average and have this output embedding that just represents the customer based on their previous history. It's very different from this like demographics features, which just, I don't know, you can use features like their statistics of logs, like how often they came, how often they clicked, but it doesn't tell anything about their like fashion interests, for instance, for Zalando. But this kind of embedding would actually have the information of their fashion interests if they like clicked on these items or purchased these items, which also turns out very powerful and like possible to use in other downstream tasks apart like from showing the next best item. Yes, so as I said, the use of transformer is this handling long-term dependencies, parallel processing, and also its adaptability in terms of like assigning weights in your user history, because if you have a user with sparse activity, so not so many actions, it can understand this and look deeper in the past to dig out more information. But then if you have like a dense sequence, it will focus on more recent actions and take out information from them. So what comes next? I think I forgot to like monitor my time. So maybe if I am I on time? Am I like maybe too fast or everything okay? Yeah? Okay, great.
We have at least 13 minutes.
13 minutes,
Yes.
Perfect. I just want to save time for the questions in the end. So, yeah, what comes next? I think it's very interesting, like, to observe what's happening now, because I think the landscape of AI is changing super fast. And I think Sam Altman said in one of his talks recently that the coding that we know it at the beginning of 2025 is going to be very different at the end of 2025. So, and basically that the change between February 2025 and February 2027 is going to be much bigger than the change from the past 2 years. So basically the jump would be even greater. So like what's ahead of us? There is a lot of interesting models evolving beyond transformers. For instance, like this state space models, which scale linearly and allow like they run much faster than classic transformers because they don't use this quadratic operations. Like when you have a matrix, it scales quadratically depending on the sequence length. And it can handle much longer sequences. So we're talking about like 1 million plus tokens for these models. Then there are this mixture of experts, the models that learn to activate only necessary weights. So you have this large language models with like billions of weights, and sometimes it's unnecessary to like activate all the weights to answer your query. And so this will become faster and cheaper. It will allow to decrease the costs. Here are like some examples of these models. Of course, like Google and some other companies are advancing because they have a lot of computational power and brain power. Neurosymbolic AI is also emerging, and I think is very interesting because it's sort of like combining understanding logic and rules with deep learning. There is this very interesting model from DeepMind. It's called alpha geometry, and it's capable to solve geometrical problems of like this math competitions, Olympiad style of math competitions, which are like very complicated, but the model can do that. Yeah, so apart from mathematical theory improving, we can use it for real world robotics and also assist scientific discovery, which is like, I think is very amazing. Yeah, and then there is this class of biologically inspired models, which are supposed to like work similarly to how the brain works and use less computational power and use less energy, and in the end, yeah, become very energy efficient and make it possible to run on edge devices like mobile phones and even train on mobile phones, which now is of course not possible. Yeah, so like the key takeaway, we expect the models to be faster, smarter, and also more interpretable, which I think is very important in terms of building trust, because I think many people are really scared of like this evolving AI. It's also like AI is a black box. We don't know what's happening inside. When we had a linear regression, it was very understandable because we knew like these are the weights, like these are covariates. We know which is important, what not. But with a black box, it's not like that. So, but I think there is also the shift towards this more interpretable AI with these neurosymbolic models. Hopefully, they will like allow more explainability. And I guess this is the last slide of my talk. I added the references for like all the articles from which I used the images and like which are most like groundbreaking in the transformer era. And yeah, I'd like very much to answer your questions.
No. Sorry. Before that, I wanted to ask you in Q&A section, I will ask you to speak on the mic since we are making recording. So, yes. Yeah, sorry for interrupting. Okay, it's going to be first.
Thank you very much. It was very interesting and very comprehensive. So I would like to ask you about the upcoming models that are supposed to be more interpretable, and this is going to increase transparency, which is an important factor for the society overall. So I wanted to ask you, can you explain this a little bit more? Is that a wish to make models more interpretable for a societal reason, or is it that it's going to advance the technology and make those models possible?
So I think it comes definitely from both sides. Thank you very much for your question. It's actually very important, and like yeah, as I said, like building trust for AI is important. I think it comes from both sides. So the models are evolving. So there's models which embed and learn the rules and supposed to embed logic understanding are actually intended also to have more explainability of the AI. I think there is like the pushes from both sides. So there is like scientific interest in this because it will make the models more powerful, and there is also a push from like advocates of explainability of AI, because then of course it can create more trust for people. So I think it comes here for both sides, like I mentioned.
Second question, yeah.
Thank you for the talk. One question about the transformer models for time series part. Mm-hmm. You mentioned something around products selling high as well as products selling low. They are trained together, so the lower selling ones learn from the high selling ones. Can you explain how does that work? Is it during training, and what happens during inference? What's the difference here?
Yeah, it happens during training. So when we learn to predict how high will be our sales, because we process everything in parallel, and we process all the SKUs, all the articles in parallel, it can actually benefit from data points which are available for another article. So basically you feed the batch to the model, right? Because like we train in this batch processing manner, and the batch would comprise of, for instance, 256 articles that have 2 years of history. And all this is fed to the model. And because you do a gradient descent on all this data, it will benefit from the articles that are in the batch that have maybe more dense time series than the other. Thank you.
I don't have a question. I was just wanting to see the references in the back.
Yeah, of course, absolutely. I can also share the slides if there is a platform where I could do that. Yeah. And it's not exhaustive, of course. Yeah, I'm also the author on one of the papers. Thanks.
One question from me is when you were training for this, for example, time series example, did you use any foundation models or it's all from scratch?
No, it was all from scratch. So back in those days, there were no foundation models for time series, definitely not. Yeah, for other use cases, they were not even a thing. It was 2019 when we first wrote. Yeah, now I'm not in the team anymore, but probably yes. So we do that for Zalando Assistant because we take foundational model and then train it on fashion data. I think we sort of do that in the image department. I don't know about time series. So yeah, maybe it would make sense, I think. Yeah.
Question. I had something connected to what the foundational models were. Right, sorry. So about foundational models itself. So one, please. Yeah, sorry. Yeah. Thank you so much. Yeah, about foundational models, one criticism for time series, one criticism is that if they are trained on a lot of variety of data, then one time series in one geography behaving completely different from a time series in a different field in a different geography. Sometimes you want them to be separate instead of learning together, right? So one criticism of foundational model is that they put it all together, which doesn't make sense. So for fashion, maybe it was a different thing. They were rated SKUs or whatever in a single geography, but otherwise, something in Nigeria was something in Canada. It doesn't make any sense. So any comment on that part?
That makes sense, yeah, and there's a lot of criticism for foundational models for time series forecasting. I think they try to mitigate these problems with different sort of solutions. So I don't know. Maybe it wouldn't make a benefit for Zalando using a foundational model because, as I said, we have a huge amount of our own data. Zalando existed for over 20 years now, and we sell so many articles. Yeah, probably wouldn't make sense. Probably would just create the noise. I think it definitely makes sense when you have little data. For instance, you open an online shop, you don't have so many articles, you don't have so much history. Then using a foundation model and fine-tuning it would make sense. Yeah, but maybe for Zalando it doesn't make sense.
Thank you for your talk. Can we just skip back to slide 17, I think?
17?
Yeah. Yeah. So in the future, this scoring, is it going to change or is it going to be some different model?
In the future, yeah, it's going to change. I mean, this is very simple representation. This is the basis, the model of 2017. It's been advanced a lot since then. So there are a lot of enhancements to this architecture. So this is basically the basis, yeah. And
so what do you think? So how it's going to change?
How it's going to change? So it's like hybrid models, so a combination of different models. So as I said, this is the core building block, but the main model is much more complex, like this thing on the right. So there is this encoder part, which has the self-attention inside, but there are also like a lot of other things going on. And some models just use this encoder part. And for the decoder, they would use, for instance, a diffusion model, which is completely different from transformer. And as I said, the mix and the hybrid models are the future. And for like diffusion models prove to be very efficient for image generation, whereas transformers are very good for language understanding. So when you have image generation based on the language prompt, it's usually a mix. So it's usually transformer in the encoder and diffusion model in the decoder. And that's, I think, is definitely the future. Like these different hybrid approaches can always like unpack benefits. Thank you.
Okay. Yeah.
I had a question about the embeddings. Are the input embeddings of variable length, or like when the size of the context or the input changes, how do they adapt to the changing sizes of the input?
Yeah, thank you for the question. So we usually use padding. We usually like take the longest sequence in our data set, and every sequence that is shorter would be padded by zeros like to the end. So the sequences, are usually made to be the same length. I think there's another question from the same person.
But like most embedding models I've seen have dimensions of, I don't know, something along the lines of 512 or 1024, dimensions, right?
This is explained by computational processing. So everything has to be power of 2, because basically like
power of 2, that part is fine, but like when they have such short dimensions, how are they able to encode information from, I don't know, like more than 4,000 tokens?
That's the dimension of just one token. So you can feed 1,000 token, but then each token would have an embedding of 128 numbers. So like it's just the size of one word, or like one prefix or suffix.
Okay, folks. So we have time for one more question in the schedule. Does anyone want to?
Could I have a fun question?
You have a question.
Okay. Would you mind if there would be a fun question?
Serious question, if there's a serious
Okay.
Fun question would be, do I have to push a button?
No, it works.
It just works. Okay, so the fun question is, when can I find blue shoes on Zalando? Because I've been looking for blue shoes a lot. And I get really bad results on blue shoes.
Really? So the search does not give you blue shoes?
Yeah, but it's maybe more a filter setting and not an
Maybe
AI problem.
Okay,
But,
this is the question to the search team. So I'm in recommendations team. We don't do search, but I will pass your question, definitely.
Okay.
I mean, that is serious. We will work on that.
But
I'll make sure they get
So in theory, if I keep looking for blue shoes,
Yeah,
it should show me more blue shoes?
of course, yeah. I mean,
So
you
just
mean
keep looking at more
you mean
blue
in
shoes
recommendations?
and hoping.
Yeah.
Yeah, but they're not blue enough.
Yeah, Zalando's not very good
I want more
yet with
blue
that.
shoes with more blue stuff, like only blue, basically.
You need to buy.
The blue caps. Yeah.
You need to buy more blue shoes. Then it will show you more blue shoes.
Okay, then Mariia, one more thanks to you.
Thank you so much. Thank you.
Hi everyone, my name is Anastasia, and today I want to represent in a few minutes Women in Agile Berlin. This is our community. We're welcoming community for people working in Agile, based in Berlin, and we provide a safe space to connect, share experience, and support each other. I just want to highlight that we are open not only for women, and we believe that agility is not just for work, it's also a way of living. And our core values, it is trust, courage, and equality, helping us grow together, and you can join us. What we provide here in Berlin, first of all, this is meetups like today's. Coffee and networking will start from April, and moreover, we will talk about how to create a trust environment in teams, what we should to do. And workshops will start in May, I hope. So this is, you can see some of our pictures. This is our team, our 5 girls. Yeah. And just the reason why I'm here today, this is a small advertising of our upcoming event. Today, my friends from Tech Actionables community talked and will continue to talk about AI, of course, and on 13th of March, we will have an online meetup about agile coaches, the perfect leaders of the AI revolution. We will talk not about only this, we will talk also about AI, how to use it and how to learn it also. And thank you for your, how to say correctly? Thank you, that's all. Yeah, just follow our link, please.
Well, second try, right? My name is Veronika Ilina, and I want to talk to you just a bit about how sharing your expertise can help both you and the tech industry. I'll cover why the tech industry needs actually our personal brands, why it might be a good idea for you personally to share your experiences, why we will talk a little bit about what might be stopping you and why it shouldn't, and how to start your personal brand as an MVP, not a full-scale investment. But first, let's get to know each other a little bit. Raise your hands, those who doesn't have a personal brand, so you don't post or talk publicly about your work life, and people outside of your current company don't know anything about you, actually. Right, nice to meet you all. Maybe I'll inspire you, maybe you will still think that you don't need it, and that's just fine. Let's see. Now raise your hands those who are just considering starting some personal brand efforts, but well, not sure how to. Yeah, almost the same hands, great. Well, I hope to help you. And now raise your hands who has a personal brand already. 1, 2, 3. Well, so there is not one expert in the room on the topic, and maybe you will chat about it later. Great. And now, raise your hands, please, those who are introverts. Not everyone.
Don't raise their hands.
Wow. Trick question. As you might notice, well, I am an introvert, and you may ask, what are you doing here even? Why are you doing this to yourself? The answer is that I see the value for myself and for you. And this value just bigger than the struggle I need to go through. So this talk is about personal brand and DevRel, whatever it means, I'll tell you just in a bit. So personal brand, aka professional brand, someone says that it's two different things. I disagree. It's an image we create about ourselves as human beings from perspectives like values, personality, and professionals, our expertise, skills, achievements, stuff like that. And I believe, once again, that these two are inseparable because, well, I couldn't share with you my expertise without like my style and my personality, right? Without all this little awkwardness. Well, it's part of me. It's not going anywhere, right? And developer relations is a practice of building and nurturing relationships between a company or technology or methodology, some like best practice, some instrument, and the tech community. And usually, this practice involves work of some like developer advocates, evangelists, community managers who are well known in their field. So this talk is about personal brand and DevRel, because personal brands and professional opinions impact industry as a whole, and I'll tell you why. To name a few, these strange DevRel people, first is Guy Kawasaki, one of the first developer evangelists out there ever. He helped developers to discover Macintosh as a platform to develop for. We can thank this specific guy for all the macOS applications ever. And now he has a humble 3 million followers on LinkedIn. Just 3 million followers, right? The second is Tara Hernandez. She was from the beginning with Mozilla, Pixar, worked at Google, now with MongoDB. She is a DevOps practices ambassador, and her efforts laid the groundwork for contemporary CI/CD. And when any of you thinks about something like, well, how to build the best CI/CD for my company, you think about something she thought first, but then just talked about it with the community. She is also a member of the board for Women Who Code, of course. And Angie Jones, also nice company titles. She's workshop instructor and mentor for women in tech, and the director of Test Automation University. And it's completely free educational platform that helped more than 75,000 of students to become, well, better test automation engineers. And the last guy is, sorry, this is a tough one, Gergely Orosz, also nice company titles, but probably you know him from the Pragmatic Engineer Substack and podcast and his book, The Software Engineer's Guidebook. He has like around 1 million subscribers and helps millions of engineers navigate technical management topics like every day. And you can say, well, cool, we are glad for all the superstars, but does everyone need to be a superstar to like somehow benefit from a personal brand? Of course, no. And these guys, Gergely, he didn't think that, well, I will start this blog and then I will make a living of it. No, but it's what happened with him. The point is, such activities actually change things in the industry. Someone worked on something, someone shared the experience, and now we have CI/CD. Wow. And it changed the industry both from technical and, well, the people points of view. It's a fact. It works for years now. So why the tech industry needs our personal brands? First, we can raise awareness and therefore adoption of best practices of our choosing. It's really convenient. But what do I know about it? Kind of all of it. 8 years ago, I also started small. I wrote articles for tech people on how to navigate like HR processes and what's happening with them at work. And since then, I've written more than 100 articles, gave more than 50 talks, and released a few open source courses. 5 years, I've been acting as head of developer relations and DevRel consultant. And I'm one of the influencers that has changed Russian tech job market to the better, I believe. And now I'm slowly working on a change, on a positive change in communications in tech in general. And I also helped more than 30 tech people to launch their personal brands and stick to it. And also I'm program committee director for the biggest online conference for tech team leaders in Russia. Sounds like bragging, right? Yeah, I know. But that's the point. That's the point. That's part of the point. Why is bragging useful? For me, it's still also really difficult to openly talk about my achievements without like downsizing them, downplaying them, since I'm not actually an engineer. Surprise. And I'm a woman working with tech people in, let's be honest, mostly male tech community. So I feel like I am an imposter in this room. Maybe I am. But I'm fine with it. Because just like I belong to a a group that isn't the most widely represented, you might be in a similar position, just from another angle. For example, as the only non-native English speaker in your community, even if you are a male engineer in tech. So we actually need to allow ourselves to brag, just a little bit, just to make sure we are seen and heard by kindred spirits, kindred introverts, for example. And well, practice makes perfect. So let's continue. Why the tech industry needs a personal brand? The second reason is that all this personal branding actually speeds up our industry development and people development. One expert can write a book or give a talk, and through this you can understand something way faster if you were to research it on your own, right? And the third reason is that sharing your story helps others to see there is an actual space for them, or someone like them in the industry, whatever some guy on the internet said. So it's all very nice, and the tech industry is probably grateful for our efforts, but what else? Yes, we can indeed make tech a better place by building some personal brand. But why else you might need it? The most important reason is that you learn the best when you try and explain something to others, teach something to others. There is this concept of learning showing that we actually learn the best things that we try and organize somehow, present somehow, dive deeper in the research, so our arguments would be the best one possible. And yeah, it works. And personal branding is just a place where you can practice it. Third reason is networking boost, and it's not just about job search, because, well, yes, people know you, you know people, great, and it might be helpful in your future job search, but it's bigger than that. It's even bigger. For example, a few years back, I was brave enough to ask a question, to ask a speaker a question after they presented at a conference. And then we had a little chat, and then it was a she, it is a she, and then I asked her to work with me on a project, and then she asked me to become her neighbor, and then she referred me to a job where I've spent 3 beautiful years thanks to her, and then she was at my wedding, for God's sake. So you never know how many beautiful people, beautiful contacts, and help you can meet through networking. And of course, when you talk to people like this, not one-on-one, but at large, you just have bigger chances to meet someone cool, right? And of course, you will improve your soft and hard skills along the way if you go this personal branding road. Because, well, maybe right now you don't need to be a cool presenter who can talk freely in a room full of people. But, right now, maybe you don't need these skills on daily basis, but in a few years you might be a head of something, a lead of something, and then, well, you will need these skills, and you better be ready. And the last but not least reason for you is that through personal branding you can get an external confirmation that you are not an imposter. Even if you say so, people will be still with you. They will nod, they will laugh, and it helps in life to not feel an imposter for a change, right? So, sounds great. Tech industry needs it. You maybe need it, right? But something is stopping you, as we started to discuss. And the question is what? I'll share what stopped me. When I just started, I was teaching, actually like teaching people how to write a CV, stuff like that. And some of them were twice my age. And it's scary to teach someone who is like twice your age, right? But what saved me was that I knew something they just didn't. So any comments what stops you from like personal branding, and why don't you start or do it at larger scale? Please, without microphone, it's okay.
Fear of public speaking.
Fear of public speaking. I will just repeat.
Okay, fear of public speaking.
Okay, fear of public speaking. We will talk about fears in general. Just a little bit later, but well, specifically about fear of public speaking, it never goes away. Surprise. But I guess I can afterwards share some life hack about it. We just did it on the interview before the meetup. Okay, any other reasons why not to do?
I'm just very interested about various topics. I'm just very intrigued about various topics,
Yeah.
and most of them there are, I believe, interesting for many people.
Yeah.
But I think if one person is of launching his own personal branding, it needs to be targeted to a specific niche, so you can address your message to your specific audience and focus on how to actually refine your message to make it even more specialized, so that it becomes something of value and quality for your audience. So that can be something that I have difficulties to navigate.
Yeah, well, perfectionism is something that can be tricky here, because I'm a fan of approach where you try different things. I will just later on give you some examples and ideas, because of course, the best way to really target your audience is to talk about specific things that are of interest for them. But, well, people are interested in many topics. Like today, we are talking about AI, the next talk about personal branding, and you are all still here. Why? Because we have this connection and common topics. So maybe you might try something wider in terms of topics. Okay, any other thoughts?
Yeah, I feel like embarrassment.
Embarrassment, wow.
Yeah, I mean, I feel like embarrassment, and
it's okay.
Yeah, and feeling that there are many more competent professionals around me that can do a better job.
Just wait a minute. We will get to it so hard, you can't believe it. Okay. Other hand, yeah. Let's try one more, and then, we go forward.
For me, it's everybody says branding right now. Everybody is doing it, so I feel like if I do start the same, it feels bothering other people.
Yeah.
If I'm on LinkedIn, I'm bombarded every day with everybody's posting all the time.
Yeah.
And to start to brand, you should start somewhere where you're already established. So if I do it and my friends see it all the time, I don't feel comfortable. They're bombarding with this stuff. So, but start from scratch somewhere else is also like weird, and everybody's doing it. So for me, it's I don't like seeing all the posts all the time. I have friends who do it, and I know it works, and it's also important. Right now, I'm looking for a job, and without brand, without visibility, people ask me, "What did you do?" I cannot show my credentials.
Yeah.
I have them, but I cannot prove them. So it's important, but to go out and present them all the time, for me, it feels like we're like bothering other people with my insights. So it feels I don't like. So it's a weird situation that you want to do it, but you feel everybody's doing. So it's I don't know how to
I
say
feel
it
you.
better.
Thanks for sharing. I believe that, well, we still can kind of manage our own attention spans, so you don't have to be responsible for others' attention. It's their choice. So, well, maybe you can try and be a little bit easier on yourself here, because there is totally things that you can share and that can be of value for your friends, even who know you pretty well already, because, well, we don't live in each other's head and we always have something to learn. So I think it's manageable. And let's talk about most popular barriers from my experience. I'm not expert enough, I'm an embarrassment, I don't have value to add. When I'm starting to talk, everyone is already talking about the same thing. Why do I start even? The lack of time, the moment when you've tried something and it just doesn't feel right, and just please, maybe it's not something for me. And of course, the fear of negative feedback, of indifference, of silence in the room, and a part of fear of public speaking, I believe, lives somewhere in here. So, first barrier, not expert enough. So, two options here. You may think that everything has already been said and you have like nothing to add at all on your topic, or you some way believe that you still don't have the million years of experience to be sure that your experience would be valuable for others. Like 10 more years and then I can say something to someone. Sounds crazy already, right? But, well, okay, let's say this is how it works. And if someone talked about something, there is no space for repetition. We always need to go deeper. We always need to create better content. We always need to give new ideas. Yes? Okay? Let's say it works like that. So why Tech Internals meetup on how to write a CV and how to pass a technical interview gathered more people than room could fit? It's the most popular topic in tech, like all this interview stuff. There are thousands of experts all over the internet, on every corner. Like, why? People chose to come to talk to the experts, to ask questions. They managed their attention once again, and they still chose to go there. Why? Because unique perspective and experience always more interesting than popular topic. And why is that? We learn by exploring different perspectives. Sometimes we need some repetition to understand something, like today with Transformers, it was beautiful. We integrate the approach that works for you, that fits our previous picture of the world. And before we find it, we might need to stumble upon the same idea, the same topic a few times. And well, this is how we learn. This is how you became engineers or whatever you do. And the same works for every topic. And every person on Earth needs to look at something multiple times from different angles before they live with it. So, looks like there is a lot of talking to be done. And we better get started because there is so many things to share, so many people who did not hear about this instrument or this part of your experience. And well, they are out there and they seek this knowledge. Why not help them? And if you still believe that you are not expert enough and you have no topics to cover and no one feel interested in anything you have to say, been there, done that. So how to find your angle for some maybe popular topic, maybe when everyone already doing something. Talk with a meetup or conference organizer, just approach them and ask what's hot. Check call for papers of conferences, because there is always specific ideas on what would be interesting for their audience, and they know their audience, and it's thousands of people, and they just share this knowledge with you, and you can just take it and find your topics there. And of course, just ask people around you, like your boss, your colleagues, because different perspective highlights our achievements better than anything. And I promise you, you will have like 10 ideas what to talk about, what to write about, if you just sit, visit, and talk with people for like half a day. The next barrier is the lack of time, and well, this one is simple. You don't have to commit to something huge. No one gives the 45-minute talks the first time they are speaking, right? There are meetups with 10-minute talks. There are internal meetups in your company. If there isn't, just create one. Why not? There is some space for like short stories on LinkedIn, Instagram, whatever place you like. So just start small and try different things and see how it goes and how it feels. Without huge goals like, I also want 3 million subscribers on LinkedIn. Well, maybe someday, but not today. You don't need to aim this high. Next barrier is when you are trying and it just isn't working. Like, well, these LinkedIn posts are so like awkward and there is no engagement and it's so difficult. Well, maybe it really doesn't work for you. It doesn't mean that something else won't. And maybe the moment when you try it just wasn't right. Maybe you were like really tired because of work or something, and maybe you just need to rest and then try again. So it's actually okay to spend some time and like from trial and effort find some way that actually works for you and is comfortable for you. For example, one of my mentees, she tried public speaking at a big professional conference and she hated it, every minute of it. She was like, why did I do this to myself? I spent so much time and it was so terrible. And I was like, oh, okay, try something else. And now she launched this like really small, she says, 30 people lectures. Sounds like public speaking for me, but it just feels different for her. And since she's comfortable, whatever. So just find something that suits you. And well, my favorite, the fear of negative feedback, that someone would come and say something like, you're just a junior, what can you add, right? You're just an amateur, you're just a girl, maybe, whatever. Well, first of all, you are the girl, the junior or the amateur or whoever you are, who has both an expertise and the guts to share it and not to just write hate comments. It's important, I believe. Secondly, here are some tips on how to avoid these difficult moments. First of all, you can use formats without comments. My favorite life hack. 8 years ago, I started this Telegram channel without comments, and since then, well, now I'm not afraid of negative comments, but comments are still not on. And it never was an issue for anyone, like, okay, who cares? And make sure to have a friendly face in the crowd. Yes, your friends that know everything about you. You know all these memes about like the one friend that likes every your post. It's not a joke, it's a serious thing that helps you in this journey. And today here I have a few friendly faces, some like people I met on previous meetups. Great, so when my joke doesn't work for all of you, it works for some of them, and it works for me then. And the last but not least is to review your materials with experts, like your colleagues, your boss, some external mentor, whatever, so they could highlight like where haters gonna hate. And you just can avoid it completely. For example, you worked with some instrument and you're like, well, I need to share it. It was quite strange an experience. Maybe someone needs it. And you write an article and you show it to your boss, and they go like, well, the article is great, but also there is an easier way. And you're like, well, I did all the work. I wrote the blog post, and there was easier way all the way long. But instead of just not posting it, think about it. There are other people with the same instrument that will Google how to deal with it. And without you, they may not find your solution and the additional easier solutions that your boss proposed and that you just can include, right? And no one would come in the comments and say, well, also, actually, there is an easier solution. It will be already there, right? So just review your materials with experts, and it will be fine. So I promised you some ideas on how to craft your personal brand MVP. Here they are. You need just three things, topics, support, and some testing. Find a community with same interests. You know the drill if you are here, but, well, I mentioned a few platforms. And just talk with people in community, your colleagues, about like cool topics, cool formats. Maybe it's time to go to TikTok. I don't know. I'm old-fashioned in this matter, but maybe for your topic it will be just what it takes. Then try and find some support. Like there is this program, I'm Remarkable. It started in Google, but now it's completely public, and it's like open workshops, online, offline, whatever, about how to like find your achievements, how to highlight them, how to be comfortable talking about them. So such groups, such communities can just support you going this road, because, well, it's difficult. It really is, and sometimes a friendly face is needed. And just to feel that you are not alone in this. And yeah, find an expert to validate your ideas. Colleagues, event organizers, whatever. But also, if it's, for example, you want to give an internal talk in your company. And of course, yes, you can show this beforehand to one of your colleagues. But if it's matter only of like structure, only general understandability, and that one thing goes after another, even your mom can do it, or your like friend, whatever. You don't need someone who is expert in your field here to like make some improvements. And then testing. Draft a list, what to try out with some test periods. Like, okay, these 2 months, every week, I will suffer and write on LinkedIn. Okay. It happens, but right when the 2 months expire, I will check and see how it goes. So like, do I have the views I wanted? I don't know, do people comment? Or isn't it working at all? And if it isn't, why? What posts worked and which doesn't? Stuff like that. So maybe you will just go and try something else. Maybe you will make some improvements, but it doesn't have to be something like, well, next 2 years I'm posting on LinkedIn 3 times a week, every day. Like, don't do this to yourself. And of course, have fun along the way, because it's no way to go without fun. So today we learned that tech industry thrives on strong personal brands and needs it every day, like everywhere. And personal branding benefits us in many, many ways. So barriers are made to be broken, and there is a way for everyone, I believe, to benefit from this. And the quest is just find something that, well, comfortable for you and feels right for you. So I encourage you, be the change, share your experience, and make the tech a better place. And show me this sign if you like the talk. I have this special guy here. Thank you. Thank you so much. And good luck with your journey, of course. Any questions? No, I am so good. You know.
Everything's pretty clear. Yes.
All right, so thank you again. I wanted to know, what would you recommend to be invited at Quality Tech Conference? So, yeah, I got invited last time, but it was more related to the brand I was working for than my personal brand. And once I have disclosed, okay, I'm coming here on an independent basis, then I realized, okay, it wasn't this anymore. Like, what would you recommend?
So they just didn't want to take you on program without your company title, or what?
Yeah, something like this. Or at least I had the feeling of it. So, because let's be honest, tech conference are also a commercial endeavor.
Sure.
I just passed by the Web Summit the other day, and that thing is massive. So yeah, it's a business as well. So there is a commercial part from the person that wants to attend this conference, and I think this is where the biggest result is to be achieved with personal branding, to be honest, because you prepare for the conference, you deliver a quality message, you're going to engage with people that are truly interested because they have actually invested a significant amount of time and money to be there. So how do I get there? On the stage.
Well, nothing new here. Start small. Attend a few meetups. First, as a participant, talk with the organizers. Eventually, you find yourself saying something like, let me give this talk about this thing this month at your meetup. And they will say yes, just because, well, you're a nice guy, you have nice ideas. Then network with the organizers and the people around them, because when a program committee decides who to take on the list, if the list is not bought fully, sometimes it happens with some huge conferences, but, well, in the good ones. When program committee decides who to take on, they always look for familiar faces. It's just what we do in our everyday life, right? And they always look for previous experience, and this is what you can provide through consistent talks and networking with organizers, with other speakers. Yeah, so for example, you might find yourself, how did we call it, Alex? The speaker that helps other speakers in need. No, so he couldn't give his talk, and he just gave me the presentation, and this is how I gave the talk.
I got also
Not this presentation, but it happens, I mean.
I got in relation to this whole topic, I have another circumstance to be shared with you, with the crowd. It's I got invited to talk about privacy law in the biggest telecom conference.
Wow.
In
Cool.
Dubai.
Cool.
So it's very nice, but I realized that I'm not in Dubai, so I have to carry myself in Dubai, and I have to stay in Dubai.
Well,
And who's going to pay for that?
Wait, and they invited you, but not provides.
That's the question as well. So who should pay? How is it going to be?
Well, usually it's the organizer's problem, but well, this. Did you try and discuss it with them?
Of course.
Okay.
I'm an open person, so.
Well, this is the strange one, but I believe that consistency and like knowing the right people will get you there, because meetup organizers often end up being some conference organizers. Like it just happens, and then, well, this is your entrance there. Yeah. No special secrets.
Let's imagine you don't have your personal brand and no one knows who is Veronika Ilina.
Okay.
What would be your first step?
Well, first of all, I would think really hard, why do I need personal brand in the first place, right? Like, what motivates me to do this? After this, you will have this like main idea that you want to share with people, like in general. Maybe this idea is that you are awesomely good in automation. Maybe this idea is something like communication can help you at work. People, please talk. Who knows? So you have this general idea, and then the question is, who is your audience, and where they are? Like, for example, if your audience are Go developers, great. Where Go developers? Where do Go developers go to like learn something new? Some meetups, some LinkedIn pages, some Slack groups, some Discord groups. Like what it is? Do the research, do the homework, and then just go there. And the very same, like. Yeah, talk with people, find the topics, share them, try different things, have fun. Here you go. Any other questions? No? So good. Amazingly good. Thank you.
Okay, so one more thanks, and we are almost